In this next section, we're going to look at how to graph linear equations, but before we do that, we're going to review how to graph points in a rectangular coordinate system. So points are described using what we call an ordered pair. An ordered pair is shown in parentheses. It has a pair of numbers separated by a comma. The first number is the x-coordinate, and that's going to describe our horizontal displacement in our picture. The second coordinate is our y value, and that's going to be the vertical displacement. So here are four ordered pairs showing first the horizontal movement and second the vertical movement. Now, some of these numbers are positive and some are negative. When it comes to horizontal movement, just looking at the picture here, you can see that left becomes our negative numbers, right will show our positive numbers. So when it comes to horizontal movement, positive numbers are going to the right, negative numbers will be going to the left. When it comes to the vertical displacement, it's a little more intuitive. Up is positive, down is negative, and so for any positive y coordinates, those will be moving up. For any negative y coordinates, those will be going down. So let's take a look at these four examples. First, we have the point, or the ordered pair, 3, 7. The 3 is my horizontal movement, and because it's positive, we're going to move horizontally to the right. So that point will be located 3 units to the right. And then the vertical movement is 7, and because it's positive, we're going to be going 7 units up. So the point 3, 7 will be located with respect to the origin 3 units to the right and 7 units up, which would put us about here. So there's the ordered pair, or the point 3, 7. Next, let's look at 5, -2. Again, the first number is our horizontal movement because it's a positive 5. We move in the positive horizontal direction, which is to the right. So we'll go 5 to the right. And then our second number is always that vertical. In this case, it's a -2, so we're going to go down 2. So with respect to the origin, which is where our x-axis and y-axis meet, from the origin, we're going to go 5 to the right and then 2 units down. So there's the point 5, -2. Next, let's look at -6, 4. Again, the first number is horizontal. Because it's negative this time, we're going to go 6 to the left. That's our negative direction for the horizontal movement. And then second coordinate is 4, so we're going to go up 4 for that vertical positive value. So 6 left, up 4. We're going to go left 6, and then up 4 will put us about here. So there is our -6, 4. And then for our last point, we have -1, -8. So again, first number is horizontal, second number is vertical. So here we will go 1 to the left because it's negative. We will go 8 down because it's negative also. So 1 to the left, and then 8 down will put us about here. So there's the point, -1, -8. So just kind of a review of how we graph points. Again, the first number is always the horizontal x value. The second number is always the vertical y value. And if we can graph points, we can now graph lines because all it takes to get a line is 2 points that we can connect with a straight line. So now that we've got the skills to do points, we'll move on to looking at lines. So now that we've seen how to graph points or ordered pairs on a rectangular coordinate system, we can use that skill to be able to graph lines. Because in reality, as long as you have 2 points, you can connect them to get a straight line. So we're going to use that skill using what's called a table of values to help organize our information. In a table of values, we'll have 2 columns, one column with x values that we'll get to choose, and then y values in the other column that we'll have to figure out using arithmetic. So the x values, I would suggest using these 7 just as a starting point because it does allow for some negative options, it allows for 0, and it allows for some positives. And what our job will be is to plug those values in. Anywhere we see x in the equation, we'll be able to then crank it out and figure out what the corresponding y value ought to be. So for example, in this first one, I'll look at my equation which said y equals x minus 4, but instead of using x, let's use this new value for x. And let's say this is now -3 minus 4. -3 minus 4 will give me -7, and so what I'm seeing is that when x is -3, the y value is -7. And so what I have achieved is now an ordered pair, x comma y, in this case -3 comma -7, and I'll be able to plot that point in a rectangular coordinate system. But one point's not enough to get a line, I do need at least two. So let's keep going here. Let's look at the next value for x that we want to plug in this case -2. So instead of x minus 4, let's take a look at -2 minus 4, which is going to give us -6. And so now we have another ordered pair, -2 comma -6. Now if you were to try and plot these points right now, you'd find that these points might not be very far apart, and so there might be a lot of wiggle room for inaccuracy if that's all you had. So what I would suggest is continuing the table to gain more points, which will result in more accuracy down the road. So let's try the next one. We want to try now x -1. So I'll write my equation y equals, instead of x minus 4, let's now do -1 minus 4, and we get -5. And so now here's a third point. Third point is great, but again, I'd like extra examples or extra points for extra accuracy. At this point, you might start noticing maybe there's a pattern happening, that I'm jumping up 1 each time I add 1 to my x. It looks like I'm adding 1 to my y. Let's see if that pattern continues. So based on the pattern, take a guess as to what the next number might be, and let's see if that's what comes out here. When we plug in 0 and subtract 4, hopefully -4 was the number you were thinking of as you were looking at the pattern here. So now what you can do is you can continue plugging and chugging to get these numbers, but if you're pretty confident you know what the pattern is, you can go ahead and fill in the rest of this. So -7, -6, -5, -4. I'm going to go ahead and fill this in, -3, -2, -1. If you're not super confident in your pattern recognizing skills, I would suggest somewhere down towards the bottom, let's check this guy and make sure we did that guess correctly. Let's plug in 3 for this last one and just make sure it comes out the way we want. So instead of x minus 4, let's do 3 minus 4, and 3 minus 4 is -1, which is what we predicted. So the pattern fell in line. And so now what we're going to do is we're going to take these 7 ordered pairs, we're going to plot them in a coordinate system as points, and then we can connect the points to get our line. Okay, so now that we have our table of values complete, we can go ahead and use those 7 ordered pairs to translate into 7 points on our coordinate system. So remember, the first coordinate is your x, that's your horizontal movement. Second coordinate is your y, that's your vertical. So we're going to go horizontally left 3 for -3, and we're going to go vertically down 7 for -7. For -2 comma -6, we'll go left 2, down 6. -1, -5, we'll go left 1, down 5. 0, -4 is just not left or right at all, staying in the center, but going down 4. And you can see that these guys are all lining up. If any one of these points was kind of out of line, you would know there was a mistake somewhere. So another reason for extra points. We get the extra accuracy and extra assurance that we haven't made a mistake. 1 comma -3 will go right 1, down 3. 2 comma -2 goes right 2, down 2. And then 3 -1 will be right 3, down 1. They all look like they're lining up, which is good. I'm going to go ahead and grab a straight edge here, and I will connect those dots with a straight edge. Once I've done that, I do need to put arrows on the ends of this line. If I didn't have arrows, I would not know that this line continues in the same fashion forever, but it ought to. So straight lines for these linear equations will have arrows. And that's really all there is to it. So we'll take a look at a few more examples where, again, we're filling in our table of values, turning those ordered pairs into points, and then just connecting the dots. Okay, so for this next example, we have a new equation, y equals -2x plus 1. We're going to do the exact same thing we did in the last example. We're going to plug in different x values, crank them out to figure out our y values. So off to the side, let's figure out what we get for y. So y equals -2. And then instead of x, I'll plug in -3. and then plus 1. Notice every time I plug in an x value, I'm putting parentheses around it. That's crucial for where we're going eventually. Let's make that a good habit. Every time we plug something in, we put parentheses around it. So now I have -2 times -3 plus 1. Based on our order of operations, we're going to multiply before we add. So -2 times -3 is 6. Now we'll take that 6 and add the 1 to get 7. So when x is -3, we have that now y is positive 7. So we'll do the same thing for the next number, and then when we start recognizing that maybe there's a pattern, we'll check our prediction one time and then we'll go ahead and let that pattern flow. So here we go back to the original, -2x. We'll have -2 times, instead of x, we'll say -2, and then plus 1. So it should match exactly what we had, it's just where there was an x, we're changing that value with each row here. So now we multiply before we add. -2 times -2 is positive 4, and then positive 4 plus that 1 is 5. So when x is -2, y is 5. Okay, so 2 points is enough to get the straight line, but as we saw last time, sometimes those points can be very close to each other, and then there's a lot of wiggle room in how we get our line and how accurate it is. So let's keep going and gather some more information. Let's try the next x value. This time we're going to try -1. So we have -2. Instead of x, we'll use -1, and then plus 1. So again, we multiply before we add. -2 times -1 is 2. If we add 1 to that, we get 3. So when x is -1, y is 3. And so at this point, when we've gotten through 3, what I would encourage you to do is see if you can catch a pattern. To go from 7 to 5, we went down by 2. To go from 5 to 3, we went down by 2. So I might predict maybe the next one might be a 1. Let's just see if that's what happens. Let's see if we go down by 2 again. Plugging in a 0 for x. -2 times 0 is 0. 0 plus 1 is 1. And it looks like that pattern's continuing. So it looks like 7 minus 2 is 5. 5 minus 2 is 3, 3 minus 2 is 1, 1 minus 2 should be -1, -1 minus 2 should give us -3, and -3 minus 2 should give us -5. So it's okay to go ahead and make those predictions, but again, I would encourage you, like we did in our last example, if you are going to go based off of a prediction, I would go into that last row and just verify that your prediction worked all the way down. So let's plug in here, instead of -2 times x, let's do -2 times this 3. And then we had plus 1. Let's see if this gives us what we want. So -2 times 3 is -6. If I add 1 to that, I do get the -5, which is what I predicted. So my prediction worked, the pattern held all the way through, but now we have that table of values. We have 7 ordered pairs that we can get 7 points from, and then we can connect the points to get our straight line. So let's see what that looks like. Okay, so we now have our table of values with 7 ordered pairs. Let's draw those as 7 points on our graph. So for -3, 7, we are going to go left 3, and then up 7. For -2, 5, we'll go left 2, up 5. -1, 3 is left 1, up 3. 0, 1 won't go left or right, it stays centered, but it will go up 1. It looks like so far these are all lining up, so it means that we've done a good job with all of our calculations. Everything's looking correct so far. 1, -1 will be right 1, down 1. 2, -3 is right 2, down 3. And then 3, -5 is right 3 and down 5. So it looks like everything's lining up. We've done a good job with our calculations. We can now take a straight edge and we can connect our dots. Again, the one thing to remember after you connect your dots, since we are graphing lines and lines need to continue forever, we are going to put arrows to indicate that. So here's our second example of graphing a line using that table of values. What we'll do in the next video is we'll look at what happens if the equation's not really set up to work well with the table of values. How do we manipulate that up front to make it work better in our favor?